Hey everybody, so welcome to our very first chapter in MAT 218 where we are going to be talking about the electrophysiology of the heart. So there are 24 slides in this PowerPoint. I'm going to try to make this as short as I can because I know it's hard to listen to someone talk like this, and this is one of the first times I've ever done a video lecture. I'm so used to teaching this class and this lesson in person, so y'all just bear with me and we're going to have to learn as we go through this. But this chapter starts assuming that you know the anatomy of the human heart. So I know that if you've had my class in the past that you have had the anatomy of the human heart. I have this pulled up right here. I'm just going to quickly show you. Here is the main part that you need to remember is the chambers. So this is the right atrium, the right ventricle, the left atrium, the left ventricle, and then you also have your valves here. So if you want to review the actual anatomy of the heart, that would be probably beneficial before you start this lesson. We are going to start with the electrophysiology of the heart. So when we had anatomy, I don't think we spent just a whole lot of time on electrophysiology, so this will be new to most of you guys. The first thing that you need to understand is knowing the difference between the electrical functions of the heart and the mechanical functions of the heart. So there's two distinct components there. The electrical impulse tells the heart to beat, and the mechanical impulse is the actual physical beating of the heart. It's the physical response to the electrical impulse that actually results in the pumping of the blood. So you cannot have the mechanical response without the electrical impulse. So that is important to know. To perform these functions, the heart has two types of cells. You have conductive cells and you have contracting cells. Conductive cells initiate the electrical activity and conduct it through the heart. Contracting cells respond to the conductive cells, and they respond to the electrical stimuli to contract and pump the blood. So it's important to know right here the heart will respond with contraction only if it is stimulated by the electrical activity. Thus, you cannot have a mechanical without an electrical. So that's kind of what I was mentioning earlier. If you know anything about electricity, the word conductive or conduction goes right along with electrical functions, even when we're not talking about the heart. So if you're trying to remember which one, conductive cells versus contracting cells, think conductive. That has to do with electrical functions. So that's how you can get those two separate and straight. And then the contracting cells have to do with the mechanical. You think of something physically contracting, that's the mechanical function. So how do we measure each one of these functions? To assess the mechanical function of the heart, we're going to assess the patient's blood pressure, pulse, and pulse ox. These determine whether or not the heart is pumping adequately. So the pumping, the actual physical pumping of the heart is mechanical. These are when the heart is pumping blood throughout the body. The way that we can assess a patient to see if their heart is pumping adequately is to measure those three things: blood pressure, pulse, and pulse ox. If any of these things are abnormal, that could tell us that the heart could be pumping inadequately. So how do we measure the heart's electrical functions or the electrical activity? The only way to do that is through an EKG machine. I think it's awesome that someone somewhere was smart enough to figure out how to create a machine that picks up the electrical impulses of the heart. And that's what this entire class is about. We're going to be studying the electrical impulses of the heart and how those electrical impulses are viewed on an EKG machine. It's important to know that there may be some occasional instances in the clinical setting where the heart muscles are not able to respond to the electrical stimuli. So in this case, you would have electrical activity but no mechanical response. So this is going to be when you see an EKG tracing that looks fairly normal, but you check your patient and there's no pulse, their blood pressure's not reading, and they're probably at this point turning blue. This is called PEA, or pulseless electrical activity, and this is a medical emergency, and you respond to it in the same way that you would respond to a full code. You initiate CPR and start coding the patient. I have seen this in the clinical setting multiple times where we will be getting a good EKG tracing on someone, and you go in to check on them and they're blue and you can't get a pulse, that's because for whatever reason their mechanical function of their heart is not responding to that electrical function. Alright, y'all need to know these words too for your test. All of this on this PowerPoint is kind of things that I've just taken from this chapter of your book, and that you do need to go memorize on the test. I like to make flashcards. It's totally up to you how you want to do this. But the polarized state is considered the ready phase. When the electrical activity flows throughout the heart, this is called the depolarization, or the electrical discharge. And then repolarization is the return of electrical charges to the original state, aka the recovery state. We'll kind of get into these a little bit more. I think it's next chapter when we start talking about what the different parts of the EKG reading means, and we will talk about how they correlate with these three words here. Alright, the conduction system. So I've already showed you guys a little quick recap of the chambers of the heart. We've got the right atrium, right ventricle, left atrium, left ventricle up here. And then the electrical conduction, here's a picture that I found, it consists of nodes. Right here we have the SA node. Then we've got the AV node. Then we have the right and left bundle branches. We've got these conduction pathways. Here, this does not have the bundle of His on it. We'll go over that in just a second. I picked this picture before I really looked at it real good, but we'll go back and make sure that y'all get that. Let me go back to my, like I said, y'all have to bear with me. So you need to understand the order of this pathway. So the conduction system starts in the SA node. So that picture that I showed you, that was the one at the very top that sits up in the it's the right atrium. It then travels to the AV node through the bundle of His to the right and left bundle branches that ends in the Purkinje fibers. So I should have looked at this picture a little bit better. It has some extra stuff on here, like we do not go over the middle internodal tract, the posterior internodal tract. That's a little more advanced than we're going to do. Bachman's bundle, we touch on that, but we're not going to spend a lot of time with it. What I want you guys to know is this is the SA node, this is the AV node, this right here is the bundle of His, okay? Right here between the AV node and the bundle branches. So then you've got your right bundle branch, your left bundle branch. And this picture calls it conduction pathways. These are actually the way your book wants you to memorize and the way that you need to memorize for your certification test. These are Purkinje fibers. So that's the order of the conduction system that you need to know, and you will need to know that for your exam. So here's a recap of that, just in kind of numerical order that might help you. I would write this down on a piece of paper. SA node, that's where the electrical impulse starts. It fires to the AV node. Through the bundle of His, it splits right and left bundle branches and then ends in the Purkinje fibers. And you can kind of look, and once we start really getting into more of the different types of heart rhythms and arrhythmias, you'll understand why it's important to know the anatomy of the heart. Because there is a mechanical, just like we talked about earlier, there is a mechanical response to every electrical response. So when something happens electrically here, then something's happening in these atrias. When it moves down into the ventricles, then the ventricles will contract. If you start having issues in certain conduction pathways, that can tell you exactly what portion of the heart. You can see on the EKG what portion of the heart, what section of the heart that is affecting physiologically, like the actual muscle wall of the heart here, if you're having problems with your bundle branches or whatever. So we'll get into that later. I don't want to get ahead of myself. All right, inherent rates. So each of the three major areas of the conduction system has its own built-in rate, called the inherent rate. And you need to know that word for your test. The built-in rate of each of the three major areas is called the inherent rate. And this inherent rate initiates an impulse at a certain speed, a certain level. This simply means that each site has a rate at which it produces impulses. So the inherent ranges of the major sites. So these are the three major sites. You have your SA node, you have your AV junction, and then you have your ventricles. So anything that happens past the AV junction, past the bundle of His, these are the ventricles, because we know that based on the anatomy of the heart, this is a ventricle, this is a ventricle. Alright, so the SA node, the inherent rate, is 60 to 100 beats per minute. Those of you that have had my class or have had any type of health science class before, you know that the normal adult heart rate is 60 to 100. So that should tell you something about the function of the SA node. The inherent rate for the AV junction is 40 to 60 beats per minute, and then the inherent rate of the ventricles are 20 to 40 beats per minute. So this information could give you a clue that if an EKG rate was between 40 and 60 beats per minute, then that electrical impulse might have originated in the AV junction, which means that possibly either the AV junction has become irritable and sped up, or that the SA node has failed and the AV junction has taken over. So the inherent rate can help interpret arrhythmias. So these are just mere guidelines, not concrete. Know that just because someone has a heart rate of 40 does not necessarily mean that they're going to have problems in their AV junction, or that they could have had an SA node failure. It's just kind of a guide, and when we start talking about these arrhythmias, it'll start making more sense. A lot of this, every week, we learn different things in this class that we build on, and at first you're going to be scratching your head thinking, I'm not really sure where she's going with this. As we go throughout our chapters, it will start making more sense as we put it all together. I think of it as like a big puzzle, and about halfway through our book, you're going to think these puzzle pieces are starting to fit together, or at least I hope you do. So the fastest inherent rate is the pacemaker of the heart. It is important to know, I'll ask you on your test, what is generally the pacemaker of the heart? What is the normal pacemaker? And that is the SA node. So the SA node is supposed to be, in a normal healthy heart, the one that is firing the impulses that tells your heart to beat. And it's supposed to keep your heart rate between 60 and 100, which we know in a normal adult, a heart rate or a pulse between 60 and 100 is considered normal. So there are two ways that your inherent rate could change, through irritability or through escape. So if a site becomes irritable and begins to, and when I say site, I'm talking about those three major areas that we talked about earlier, right here, SA node, AV junction, and ventricles. So if a site becomes irritable and begins to discharge impulses at a faster rate than normal, then it can override that normal pacemaker of the heart and take over. So for example, the SA node is discharging at a rate of 72 beats per minute, or 72 impulses per minute, and the AV node begins to fire at a rate of 92 because for some reason that AV node has become irritable. Then the AV junction is going to become the pacemaker. How are we going to know that that happens? There's going to be little clues on your EKG readings that will show you that that is an atrial or AV junction reading. And like I said, a lot of this will make more sense later. So don't give up after you hear this very first lecture and think, oh my gosh, this is over my head. It's going to fit together eventually. Alright, the mechanism of an irritable site speeding up is called irritability. That's what we were just talking about. This is usually undesirable, which means this is usually not what you want to happen, because for whatever reason that site has overridden the normal pacemaker of the heart, the SA node. Something different happens if the normal pacemaker slows down. If the SA node drops below the inherent rate of 60 to 100, or if it just fails completely. So the site with the next highest inherent rate would then take over. This would be the AV junction first. This is called escape. This is literally your heart's built-in safety mechanism. If one site fails, you have a safety net under that site. And then if that site fails, then you have a safety net under that site. Once you get down to the ventricles, which the inherent rate is, we just read that the inherent rate of the ventricles is 20 to 40. Once you get to that one, there is no safety net under that. If that fails, that's a point of no return where your patient is probably past the point of return. They're not going to make it. All right, so that mechanism is called escape. So remember, irritability is when a lower site speeds up and takes over as pacemaker of the heart, and escape is when the normal pacemaker of the heart, the SA node, for some reason has failed, or it has slowed down and is not firing impulses between 60 and 100. So then the AV junction would take over. So as a rule regarding the pacemaker of the heart, the site that initiates the impulse at the fastest rate becomes the pacemaker. Now in a normal heart, we want the pacemaker to be the SA node. This node right here. This is the SA node, the sinoatrial node. But sometimes this SA node, for whatever reason, it just poops out and it doesn't fire as quickly as it should. Well, then this AV node's going to take over, and at that point your heart rate's probably going to slow. Or if the AV node becomes irritable for whatever reason, then the SA node is overrode by the AV node, and you're going to have some type of arrhythmia, and your heart rate might even be faster. Alright, we're getting through this pretty quickly, guys. I'm trying to be fast because I know that y'all are not going to watch. It looks like we're about 15 minutes in. And I would advise you guys, if you're checking out, like when I'm watching the videos sometimes and I'm just like, I just know I need to get through this, just pause it and even back up if you think, okay, I didn't hear what she said there, or I didn't get what she said. Just back up and listen to it again. It might even be good to listen to this over and over again just so it sticks. I personally, if I were listening to an audio lecture or a video lecture like this, I would take notes just like I would in class. And those of you that have had me before, you know, if I emphasize something, it's going to be on the test. It's important. All right, nervous system influences. In addition to the inherent rates, the heart also can be influenced by the autonomic nervous system, the ANS. So if you've had basic anatomy, you kind of know a little bit about that autonomic nervous system. We're not going to get into too much detail about it, but I want you to know one simple difference between the sympathetic and parasympathetic nervous system and how it affects the heart. Like I said, we're not going to get super into it. The sympathetic branch influences both the atria and the ventricles. If the sympathetic branch is stimulated, then the atria and ventricles will react in these ways. They'll increase their rate, and they'll increase their induction through the AV node, and they could increase their irritability. So just the main word here is increased. Okay, sympathetic branch influences the heart in a way that it increases everything. It increases the rate, it increases conduction. The parasympathetic branch is opposite. It influences only the atria, and it causes the atria to slow down, as well as slows conduction through the AV node. So it's going to decrease your rate. When I was in nursing school, the way that my critical care instructor, when she was teaching electroactivity, electrical conduction of the heart, she said that the way she remembers it is when you go on vacation, you typically go to paradise. And when you go on vacation, you slow down. You slow everything down. So paradise, parasympathetic. Think about that. So if I ask you a question, which part of the autonomic nervous system slows your heart rate? Think of paradise, vacation, slow down, parasympathetic. Those of y'all that have had me before know that I like to think of little silly things like that just to kind of help me remember keywords. All right, key points of this chapter. Just a recap, I'm just going to speed through this. The heart has two types of cells, and let me add, if it's in the key points, it's going to be on your exam. The heart has two types of cells, electrical and mechanical. What are electrical cells responsible for? Initiating the electrical activity of the heart. What are the mechanical cells responsible for? They are responsible for initiating the actual beating, the pumping of the blood. And remember, there are also two types of cells within those two functions. So you have conductive cells and contracting cells. So conductive goes with the electrical function, contracting goes with the mechanical function. Electrical activity precedes mechanical activity. Precedes means comes before. So that just means that you have to have the electrical activity to have the mechanical activity. Now remember, we talked about that weird phenomenon called PEA. There could be times where you have where you have electrical activity with no mechanical activity. That's called PEA, pulseless electrical activity. It's electrical activity with no pulse. But you cannot have mechanical activity without the electrical activity. If your electrical activity is not working, your heart is not beating. There is no mechanical function without electrical function. And that sometimes, we'll talk about this later, but just if you've ever heard of someone that has a pacemaker, that's what that is. The electrical function of their heart is malfunctioning in some area. I don't know what area. Maybe you know someone who's had issues with that. Their electrical function has caused their heart to be pumping inadequately. So that a pacemaker is an external or internal sometimes device that they implant in the heart that literally just initiates those impulses for the heart. Depolarization is the discharge. Think of depolarization, discharge. Repolarization is the return of the electrical activity to the original state, and I think I skipped polarization. And polarization is when the electrical charges are balanced and ready to be discharged. So you've got polarized, depolarized, and then it repolarizes, and then it starts all over. And that little, those three things right there in that order is what happens with every single EKG reading, with every single complex that we look at when we start looking at those complexes. All right, you need to know the electrical flow through the heart. the conduction system. So it starts with the SA node, the sinoatrial node, goes through the AV node, through the bundle of His, through the right splits and goes through the right and left bundle branches, and then ends in the Purkinje fibers. You need to know the inherent rates of each of these major places here. So the SA node inherent rate 60 to 100. The SA node is the normal pacemaker of the heart. The AV node inherent rate is 40 to 60, and the ventricular rate is 20 to 40. The site with the fastest rate will be the pacemaker, and the normal pacemaker of the heart is 60 to 100. Again, this is just a recap of what we talked about earlier. There are two functions or two ways that a pacemaker can assume its role: through irritability or escape. So irritability is when a lower site speeds up and takes over as pacemaker, and escape is when the normal pacemaker, the SA node, slows down or fails, and then you have that fail-safe net underneath it that takes over. Remember, sympathetic stimulation increases the heart rate, and parasympathetic decreases the heart rate. I've also added a couple of YouTube videos here. Let me click on this one. You do not have to watch these.
The cardiac conduction system consists
right
of the
now.
following
I'm going to pause
components.
this. These are little short videos that I don't necessarily love the video because the guy's super monotone. You are probably thinking, well, you're super monotone, but the guy is a little hard to listen to, but it's only 3.5 minutes, and it shows a nice little animation. I'm a visual person. I got to see things, so this is a good little animation. So I have posted my PowerPoint for you guys to view. So those links are in the last slide of my PowerPoint. There's also another one here that shows the actual cardiac conduction system.
The heart's conduction system
As an animation and as it is reflected on an EKG reading, which is really a little bit more of what we're going to get into next week. But I'm just kind of introducing you to it this week. So I would advise you guys to watch both of those YouTube videos that are embedded in this. If for some reason these links don't work, someone shoot me a message, and I'll post them into Canvas as like a lone video. I don't know. These links work for me, but they may not work for you guys, so we'll make sure that they work. Alright, well that's it. So you will have a test every Tuesday in this class, okay? I will do this every week. Every Sunday I will release a video lecture where I will give you the notes and the PowerPoint. Now yes, you can view the PowerPoint on your own every week. I would advise you to watch these videos because I give little snippets of information in these videos that maybe you would not get if you just read the slides by yourself. So I would advise you, and also too, I am learning how to embed quizzes into these videos, and as soon as I figure it out, I am going to start embedding questions into the middle of these video lectures, so they will just randomly pop up and you have to answer them, and you will get a grade on them. So be sure to watch these every week, please. This is taking the place of class. Normally I give these lectures in class, and I love that because it's interactive and we can talk to each other and you can ask questions when you don't understand. So feel free to ask questions. Those of you that have me in class or at school, ask questions about the video lecture. If you don't have me in class, shoot me an email, or when we have labs on Tuesdays, please feel free to ask me to clarify something. So the test for Chapter 1 is going to be on Tuesday. Now, I would prefer that you take this test on campus in our lab time. Every Tuesday is when I'll be administering the test. If you cannot, then you will have to use Proctorio or Respondus Lockdown Browser, and you need to make arrangements ahead of time. Let me know what you're going to be doing, if you're going to take it on campus or if you're going to take it up through Proctorio, and I will make arrangements for you. And it will need to be taken on Tuesday. So my tests are every Tuesday the week after I cover the lesson. So this week we'll have lab. We'll recap a few things. We won't have a test this Tuesday because we don't have anything to test on. You'll study this stuff all week long. I'll post a couple of assignments. I want you to read this chapter in your textbook. Now, I didn't go over every single thing in this chapter. I hit the high points of what the NHA says you need to know for your certification exam. But I really would advise you guys to read the text if you have it. If you don't have it and want to look at it at my textbook on Tuesday, you're more than welcome to. I don't care to make a few copies of some pages for you. But just let me know. So I'll see you guys Tuesday. Be ready to go in the lab and hopefully get to work. We'll let a few of you do some EKGs. Those of you that aren't doing EKGs, we're going to be working on some worksheets in the lab of analyzing EKGs starting this week or next week, and I'm also going to get you guys registered with the NHA. So y'all have a great weekend, rest of the weekend. I'll see you guys Tuesday, and again, if you have any questions, please let me know. Thanks.